Never? You have done it yet? From your project, you design the ER diagram and then you transform it to the table, right? Okay, today is how. Exactly how. Okay. Actually, they have several steps, like mapping regular entity to relation, weak entity, one-to-one, one-to-many, many-to-many to the table, and multi-value attributes. Yeah, it is a very important one. And an array relationship type. And also, if you have specialization, generalization, this slide will show you how to transform them to the relational table and also the union type. So, the goal of the mapping is to preserve all information, all attributes in the ER diagram and also relation still contained in the relational table, right? Maintain constraints to the extent possible. Relational model cannot preserve all constraints, such as the maximum cardinality ratio 1 to 10 in ER. If just one table, sometimes you cannot contain this kind of the constraint, right? And exhaustive classification into subtypes. For example, students specialize to domestic and foreign. And the goal of the mapping is to minimize null values. If you don't use the several tables, just use one table to to store all of the information, you will have a lot of null values in the table. So the way to transform is one of the goal is to reduce or minimize the null value in the tables. Okay. Actually, next time, maybe next or next 2 times, we were talking about the normalization. Normalization is try to check the null value and try to separate the table into the small one in order to reduce the null value in the tables. Okay, anyway, today we're just talking about how to transform the information from the ER diagram to the relational table. Okay, the first one, ER to relational mapping algorithm. We call it algorithm. Just step to check and transform it. The first one we're talking about regular entity. For each regular one or strong entity, entity E. Okay, in ER schema create relation R that includes all simple attributes of entity E. Okay, choose one of the key attributes of E as a primary key for the relation R. If the chosen key E is a composite, the set of simple attributes that from it will together form a primary key of R. Okay, this is how we map regular entity to the relational. For example, we create relation employee. Okay, actually employee entity is a strong entity and also department project. All of them are the strong entity. So we can transform them directly to the relational table. Here they show us the SSN from employee is the primary key, right? And department, D number is the primary key and P number is the primary key of the project. All of them are primary keys for relations employee, department and project. Let's see. Employee, department, project. Okay, why? Which one? Employee, department and project. Okay, For employee, the key is SSN. That's all. But how many field in this relation employee? How many? We have 1, 2, 3, 4, 5, 6. 6 attributes, but one of them is name. We call this kind of attribute as composite attribute. And the name, including F name, middle name, and last name. Okay. And the other one, department. Department, we have name of the department, right? Can be a key. And number can be a key, but we select the number as a primary key of the relation department. But for location is multiple value. Okay. And project, we have 2, right? Name and number. And we select the num as the primary key. Okay, here is information from the entity. This one is just general one, regular one. But okay, let's see what is happened for each of them. For we're talking about the name, which is the composite, right? The name. Now this appear just only the details of the composite attribute. So we just add F name, minute, and last name in the table, not including the name here. As you can see, we have name, right? But the columns in the relation, we use just the details of them. This become like this, employee. And the other one just contain the details of the entity. But the other one, which one? Department, we have several locations. Let's see department. Department actually, from the attribute, we have just only D name and D number. But the locations we store in the other table, and we will be talking about it later, okay? But for department, we have the number and the name already. Why they use several different names? Sorry about that. N name should be D name, and D num. And the other one, project. We have name and number, right? Project. P name and P num here. But location, actually, we also, okay, just one location for one project. So we have 3 attributes at least. 1, 2, 3. Okay, all of them. Just that. But only one thing we didn't talk about is multi-value for the location. We'll be talking about it later. Okay, new one. Include all simple attributes of the weak entity. Also includes as foreign key attribute of the primary key attribute of the relations that correspond to the owner entity type. The primary key R is the combination of the primary key of the owner entity and the partial key of the weak entity type W, if any. Okay, let's see the relation. Create a relation dependent in this step to correspond to weak entity type dependent. Okay, we include the primary key SSN of the employee relation as foreign key attribute of dependent. name ESSN, and the primary key of dependent relation is combination between the primary key that we borrow from employee become ESSN and the partial key of the weak entity dependent name. We have to use both of them as the primary key of the weak entity, because now here the dependent name is the partial key of dependent. Back to this relation. Okay, now we're talking about this relation dependent. Here dependent is the weak entity, right? And the weak entity, we have name of dependent as the partial key, but sometimes name might duplicate, so name only cannot be the key of dependent. We have to borrow the key of the owner. Owner is this relation owner. Employee is the owner of this relation. Okay, we have to borrow SSN to help compare with the name and use them together as the key. So here dependent, actually we have 1, 2, 3, 4 attributes, right? We have 4 attributes, but when we transform it to dependent as dependent name, okay, just dependent name only cannot be the key because sometimes it's duplicate. We have the sex, birthday, relationship, the details of the entity, attribute of the entity, right? And we borrow ESSN from the owner of the relationship with dependent. So we use both of them together as the key of dependent relation. So when they pair together, it becomes stronger. It's not duplicate anymore. Except, actually in this example, it's not good. Sometimes if you are dependent, like if you have father and son, and your father named Smith, and your son also named Smith, what has happened? It's still duplication, right? You have to use relationship also, but it's too complicated for this example. But I would like to give you, sometimes it might be some problem can be occur in some case, just only some case, just very rare, very rare. Okay. So now we know how to, in ER schema, identify the relation S and T that correspond to the entity type of participating in R. So there are 3 possible approaches. Wow, 3. The first one, foreign key. You approach. You choose one of the relation, say S, include foreign key in S, the primary key of T. Okay. It is better to choose an entity type with total participation in R in the row of S. For example, relation managers. Okay, relation managers is mapped by choosing the participating entity type department to serve in the row of S, because its participation in managed relationship type is total. Let's see the ER diagram. Now we're talking about employee and department, right? And here on the right hand side, department and manages total participation. That means every department every department will have manager. But on the left hand side, it's not total, this is partial. So not all of employees are manager, just some of them. So when you would like to store this kind of relation and you add the primary key, add the foreign key, which one you will select to add the relation? If you add the department of the manager on employee, what has happened? Just sum of employee is the manager, right? So that column will contain a lot of now value. But if you add the key in the department, the key of employee in the department as the manager, so every department must have value because all of department has manager, right? So when the transform has manager, right? Manager SSN. So department A, manager 1, department B, manager 2. For all of them, all of departments have the manager. But for employee, what has happened? Not all employee are the managers, right? Just some of them. So if you have the department number of manager, something like that, it will be a lot of now value contained in the employee table. That's why they select the total participation site to add the foreign key. Okay. Makes sense, right? Okay, and then merge the relation option. Okay, an alternative mapping of one-to-one relationship type is possible by merging the two entity types and the relationship into single relation. This may be appropriate when both participation are total. Okay, of course, if both participation are total, you can select foreign key approach also, okay, or merge them together. That's fine. No, not all case. Okay, but one option is merge them together and cross reference or relationship relation option. The third alternative is to set up a third relation R. You have one relation and the second relation, and you create the other one. The other one just contain the information of the relation by reference using the primary key of both entity into the new relation. But actually for this approach, the problem will happen when you search or query them, because you have to join 3 tables at a time. So it will have like computational cost to merge all of the information. But maybe easier to understand. What else? Mapping. Okay, one-to-many relationship. For each regular binary, one-to-many relationship type R. Okay. Identify the relation S that represent the participating entity type at the end side of relationship type. Include a foreign key in S, the primary key of the relation T that represent the other entity type participating in R. Include any simple attribute of the one-to-many relation type as attribute S. explanation is quite complicated. Okay, let's see. Example 1 to many. Works for. Works for. Works for is relation between the employee and department, right? One employee work for just one department, but one department has many employees work for. Okay, so let's see the relation here. Works for is on the top here. Works for department. Now we have relation for employee already. We have department information already. How to contain the relation between them? The work for relation. As you can see, both of them are total participations, total. But on the left is n. On the right is just 1. If you add the employee SSN into the department table, what is happen? One department has many employee. Impossible, right? But for employee, one row. Employee Smith works for one department, just only one information. So it's not complicated. As the result of the mapping, employee work for which department? But you can imagine that if you want to store the employee in the department table, what is happen? You have to add all of the employee here. It's impossible to add the employee in the department. It's very makes sense. Okay, you add the foreign key of the other side to the entity of the end side. So in this relation work for, we have department table, department relation and employee relation. And employee is in the end side, many is here. So we add D and O from the other side of the relation in the employee table to store the relation work for. Okay. And then mapping binary many to many relationship. Okay, now we have many to many. For each regular binary many to many relationship type are create a new relation. This is very important. Create a new one. Create the new one. S to represent R, represent the relation. This is really relationship relation. Okay, include all as foreign key attribute in S. S is the new one, right? S is the new relationship. The primary key of the relation represent the participating entity types, their combination will form the primary key S. Okay, if we have a new relation, we have to use the key from the entity of the relation, both of them, to combination as the new key for the new relation. Also include any simple attribute of the many to many relationship type as attribute of S. For example, works on relation, works on, not work for. Work for is employee and department, but works on is on the project and employee. So the primary key of the project and employee relations are included as a foreign key in works on, and rename the project name P name to be PNO, and SSN from employee change to ESSN. Attribute hours in works on represent the hours attribute of the relationship, relation type, and the primary key of works on relation is the combination of the foreign key attribute ESSN and PNO. At first, let's see the ER diagram. Now we're talking about the works on relation here, and this relation has one attribute hours in this relation, and employee we have SSN as the primary key, and project we have actually PNO, project number as the key. So if you have this kind of relation many to many, you have to create a new relation, new table. Okay, new table. And the new table must have key from both entity of the relation. So the new table will have SSN and also P number combined together as the key to show this relation, and also include the attribute of the relation, that is ours. The results become here, and employee in the top one. Then we would like to have to the table to store the relation many to many, but one employee works on several projects, many projects. You cannot add the project in the employee table because we have several values. And also in the project, many employee works on the project, so you cannot add several employee are in the project table also. So we have to create a new one, and you can name it. Here we call using the relation of the name, relation name as the name of the table, and we use the key from from the employee and use the key from project paired together, and we have attribute hours. Now we can know who works on which project and how many hours they work for the project. And we can store, if you works for several projects, of course you can have several rows in this table, right? And you can summarize one project, how many employee works on this project using works on table also. So this table will store the information of the many to many relation. For we already mapped the strong entity, weak entity, one-to-one relation, one-to-many relation, and the last one now is many-to-many. Okay. Next, multi-value attributes. So for each multi-value attribute, A, create a new relation, new table, R. This relation R will include an attribute corresponding to the attribute multi-value attribute, plus the primary key attribute K as a foreign key in R of the relation that represents the entity type of relationship type that has A is the multi-value attribute as attribute. The primary key of R is the combination of A and K. If the multi-value attribute is composite, we include its simple component. Let's see department locations. One department might have several locations, right? So we separate the location as attribute. Location attribute is the multi-value attribute, but we cannot store the multi-value in the table department. We have to separate them into the other table. Now we name it D location. Oh, the location is attribute name. Sorry. Now, so they multi-value attribute location of department. Okay. Why D number as foreign key? They set up the D number as the foreign key represent the primary key of department relation. The primary key of R is combination D norm and D location. So let's see the ER. As we mentioned at the first place here, the location and number here. You have multi-value, right? Multi-value of the department location. We have one department has several locations. In department, if we store several locations in the department, can we do that? Yes, but difficult to process later. So we separate them to depth locations here and use the primary key of the entity to be part of the key, partial key in the new table. And the multi-value has to pair with the foreign key to be a key. So you have to use both of them as a key. For example, first department location Pattaya, but the first department has only one at Pattaya, right? If they have several locations, if they have several branches in Pattaya, what should we do? So we have to assign more information to separate them. Anyway, sorry, don't think about that. Okay, just one location for, how to say it? Okay, the one department for one location, we have to combine them together as the primary key of the table department locations. Okay, they store just that information. So if one department location are Pattaya, Krungthep, Chiang Mai, so we have number 1 with Pattaya, number 1 with Chiang Mai, number 1 with Bangkok, something like that. And we have to use both of them as the primary key. Can you remember concept of primary key? Unique value. That's all. Unique value. If just one row, if just one column cannot be the unique value, you have to compare. You have to combine with the other one to be unique value for each row. If become unique value, you can select them as a to represent R. Include as foreign key attributes in S the primary keys of the relations that represent the participating entity types. Also include any simple attributes of an array relationship type as attribute S. For example, here is the supply relationship. Supply relationship in I will show you later in the ER on the next slide. This can be mapped to the relation supply show in the relational schema, whose primary key is combination of the 3 foreign keys. Let's see the ER. Here is n-ary. This one is ternary. 3. Entity participate in the relationship. And supply has S name as the primary key. Project has project name as primary key, and the part has part number as primary key. So if you have ternary or n-ary, you just create the new table and use the primary key of the participating entity, combine them together and become the key as a relation. And also don't forget the attribute of the relation in the table. So the new table will become here the supply. Right. Now we have 3 entity participate in the supply relationship. So we have to bring them all. And the key from supplier, the key from project, the key from the part number, and use them all together as the primary key of the new relation or the new table. And don't forget this one, the attribute of the relation. So you can mapping the relationship n-ary to this kind of the table. Okay. So today, when you're going home, please check your table in the project. Did you use this kind of the technique correctly or not? Okay. But maybe you already fine. So now we're talking about the entity, big entity, one-to-one relationship, one-to-many, many-to-many, and then what else? Relationship, right? N-array and multi-value already. Oh, a lot of things. So what else? This is summarization, correspondence between the ER and relational model. Okay, this is just summary. If you cannot remember, that's fine, but you should remember some example when you have to mapping the ER diagram to the relation. Okay. So next, mapping generalization and specialization hierarchies to relational schema. Okay, a lot of text, sorry. I so tired. Options of mapping, specialization or generalization. Okay, convert each specialization with M subclass. So we have superclass and subclass. Oh, sorry, this one we have M subclass and generalized superclass here. Oh, yes, right. C. S1, S2, SM is subclass, R subclass, and C is a superclass, where attributes of C are K. K is the key, and the other attributes, and K, okay, K is the key, and into relation schema using one of 4 following options. So from specialization or generalization, we have 4 techniques. Multiple relationship superclass, subclass, and multiple relation superclass, relation only. Single relation with one type attribute, and single relation multiple type attributes. Okay, let's see the first one. Option A. From generalization and super specialization. Okay, the first one. A. Multiple relations, superclass and subclasses. You have to create a relation L for superclass C with attribute L including K and the other attributes, and the primary key of L is K. Okay, create a relation Li for each subclass Si. For each subclass, you will have separate table for each subclass. And attribute Li equal K union attribute A of Si. And primary key Li is K. This option works for any specialization, although they are total, partial, disjoint of overlapping option. Okay, for A, what is happening? Let's see. This is the specialization from the employee, and we have separate, right? We separate the job type using job type to be secretary with the attribute typing speed, and the other one technician has attribute T grade, and engineer has engineer type. So this one is specialization using job type. So from the option A, we have the superclass of information. For the superclass employee, here is generalized one, right? We have just first name, middle name, and last name, and SSN is the key. SSN is the key of the superclass, and we have birth date, address, job type. Okay, so we just separate them for each superclass, specialization subclass. So we have superclass table here, employee, and the key is just SSN, and the other one for each subclass we have 3 subclass. Secretary, don't forget the primary key SSN and the foreign key also, but this one is the primary key of the table, and technician SSN is primary key, and engineer is primary key. Now, actually here, don't identify disjoint or overlap. But you can imagine that if one employee belongs to 2 subclass, what is happened? We can store the data, right? If one employee is a secretary and also a technician, we just store them in the both of the table. That's all. Very simple. But the problem is when you join the table, it's a huge computational cost we need, because you have to join all of them together when you want to check something. But the techniques to reduce this kind of computational cost, you don't have to join 4 tables all the times, but you need some program to check here the job type, and use if in the program. If the job type is secretary, you just join the table employee and the secretary. If the job type is technician, you just join employee and the technician to get the information. So you can reduce the computational cost, but you have to do something more, like create a program to check the job type. Okay. Anyway, you can store the information, no problem. But when you try to retrieve the information, you have to optimize them. If not, it's quite a problem for computational. It's a huge computational cost. Okay. And the other, we already talked about A. We create the superclass table and the subclass table for each of them. For B, multiple relations, subclass relations only. Okay. Create relation Li for each subclass. SI. Then attributes attribute from SI subclass union K A1 to AN, all of the attributes of the superclass. This option only works for specialization whose subclass are total. Every entity belong to one or two subclass. One or more. Okay, let's see here. Now we have a vehicle, right? And don't forget total participation. Each vehicle can be a car or a truck, because of this one is disjoint, can be just belong to one subclass. But for overlap, that's fine. You can use this kind of technique also. Okay, but this in this example is total participation and also disjoint. Okay, and for car we have two attributes, and for truck we also have two attributes. Okay, so actually from this information we can separate them into here, right? Actually this is the original one, and then when you create the ER or ER you can combine them together to be this one. But the original is the car has the vehicle ID and license number and also price. For truck you also have license plate number, vehicle ID and also price. Similar, right? If similar, you can combine them as a superclass. Anyway, now this one is total participation, so you can use this technique to separate the table into subclass table, just only subclass. Car and truck only. We don't have to create the superclass. You can ignore that. And the information of the superclass, you just merge them to be the subclass relation. From the superclass, you can see that we have vehicle, a minute. Here, vehicle ID, price and license plate, right? So we also have use the superclass here. Combine them together with the attributes of the subclass. This is from subclass. This is from subclass. From subclass. Sub. Just only for the total participation, because if this one is partial, what is happened? This one is just vehicle, not truck or car, but we have ID and license number. If you change to this table, what is happened? We cannot store. We cannot store the data in each of them, because the vehicle maybe is the bicycle, not a car or a truck, so the data cannot store in any table, is gone. So it becomes a problem. Don't forget that. This technique can be used just only total participation. This is option B. Okay. Next, option C. Single relation with one type attribute. Single relation with one type attribute. Create single relation L with attributes from L K and the other attribute, and also the attributes from subset, subclass, from all subclass, union them together. And T, here is special one, T. The attribute T called discriminating attribute that indicate the subclass to which each tuple belongs. Okay. Let's see C. Actually, from this example, employee, we have subclass secretary, technician, and engineer. They are subclass, okay. And discriminating is T, okay. So when we use T techniques, is like this one. We have for the super class is here, but this one, the job type is the T to separate. And the other one are attribute from S1, right? This one is attribute from S2, and here is from S3. Typing speed is attribute from secretary. T grade is from subclass technician, and the other one I'm writing here is like engineer type. But we need the T to discriminate, and in the attribute already contain this discriminating attribute, so you don't have to add more. Okay. And what else? See already. D, single relation with multiple type attributes. Okay. Create single relation schema L with attribute key and the other attribute union with the attribute of subclass, and union T1 to 3 to M. And here the T, the new one, is are the set of the Boolean type attribute as the flag to indicate whether a tuple belong to the subclass. Actually, we have to emphasize that here. The C, you can store just only disjoint, right? Because in job type, you can add only one value. So, one employee belong to just only one subclass. But for this technique, D, you can use multiple subset, belong to multiple subset, that's fine. Multiple subclass, that's fine. So we have the Boolean as the flag, T. Let's see D dog. D, where's the D? Here. Okay. Now, as you can see, the part is superclass, and here is the overlapping. The part can be the manufacture part. The part also can be the purchase part, but the same part number. So we can use the D techniques. Okay, we have part number description. Here is the attributes from superclass. And this one is the T1. It's like a flag to show that each row belong to, this one is T2, belong to which one? if both of them are true and true or 1 and 1, so the part might have the part from manufacturer and also from the other subclass. Oh, sorry. This card at the same time. But don't forget that this is the difficult one, because this is total participation. Total is mean all of the part must belong to one of them or both of them. So when you insert the data into the table, you cannot add the data only this part into the superclass. You have to check it somehow. Okay. Now, it shows how to map the specialization and generalization to the relation. The first one, multiple relations, superclass and subclass. So the table will have the table of superclass, right? And the others are subclass. This is A technique. And B, multiple relationship, subclass relationship only. So the relation will be the only subclass tables, okay? Only subclass tables remain. But don't forget that this one must be the total participation only. And C, we need the attribute T. Attribute T to discriminate the type of the subclass. This one is remain only one relation or one table, but we need one attribute as a discriminator to discriminate them, to show the superclass belong to which subclass. And the last one is the single relation with multiple type attributes. This means the superclass belong to several subclasses. That's fine. So we need the flag, the Boolean flag, to identify which class of the superclass is belong to. Okay. Yes. And then different type of mapping, generalization, hierarchies. Now, options for mapping specialization or generalization. They will show you the mapping ER schema in figure 4.4, option A. Option A. This is slide summary, okay? And next is option B, C, and D. So here the first one is from option A. You will have the superclass table and the subclass table. For option B, only subclass table. Option C and D, combine them together. But for C, you need the discriminator. Which one? Job type is discriminator to discriminate the subclass of the superclass. But for D, you must have the flag, is Boolean, to discriminate. Oh, non-discriminate, to show what which subclass the superclass belong to. This one is sub. SB. Oh, too dirty. Sorry. SB. SB subclass, no? Subclass. And it's superclass. Yeah. And you have to understand the conditions of them. Which one? What kind of the